is stoichiometry tutorial number 3. We will be calculating molarity during this tutorial, and you'll need a calculator, a periodic table, and the worksheet that accompanies this tutorial. So first of all, what is molarity? If you look at your map of molands, you might have noticed that there was a location there that had molarity. And it says to get to molarity, you're going to use moles per liter. And that's exactly what the molarity is. It's a concentration that expresses the moles of solute in 1 liter of solution. So by finding the molarity, we're finding just how concentrated a solution is. Our equation for molarity is here in the middle of the page. We have the moles of solute divided by the number of liters in solution, and that will find the molarity. And then we use this capital M to represent the unit for molarity. And so if you made this calculation and you have a 6 M, we say this is a 6 molar solution of hydrochloric acid, possibly. So once again, the molar is just there to describe the concentration of solution. Now the thing we have to remember when we're using molarity is that often in lab we're using milliliters. If we're using a graduated cylinder or beaker, we're not using liters, we're using milliliters. And so this is going to be very common when we're making calculations for molarity. So you need to know that 1 liter is equal to 1,000 milliliters. Definitely very common. And then the next thing is that the molarity can be used as a conversion factor. And so once we learn how to complete these molarity calculations, we will go on and use them in a series of conversions to convert from one unit to another. So here's our first problem. It states that we have 0.5 moles of sodium chloride, and it's dissolved to make 0.05 liters of solution. So we can plug these numbers into our equation for molarity. So the equation for molarity, it was at the bottom of the page, but it was covered up. It is the number of moles divided by the number of liters. So we can place these numbers in. We have our number of moles and the number of liters given to us. And so this is a real easy plug and go. So we have 0.5 moles of sodium chloride. And we will divide that by 0.05 liters of our solution. Plug these numbers into your calculator, and you should get 10. Now remember, what is the unit for molarity? It is a capital M. And so here we would say you have a 10 molar solution of sodium chloride, and I'm going to write that out down here. A 10 molar solution of sodium chloride. Moving on to the next one. Number 4, 0.5 grams of sodium chloride is dissolved to make 0.05 liters of solution. So in this case, we're not given moles, but we have to have moles of our solute to be able to find the molarity. The good thing is with this, we have learned how to calculate or convert grams to moles long ago. And so it's a real simple conversion. We are going to start with our 0.5 grams of sodium chloride. And we still want to find the molarity, but first we have to go from grams to moles. So let's calculate the molar mass. Remember, for molar mass, we're going to look at our formula, which is NaCl. And we're going to combine the atomic mass of each component of this compound. So for sodium, we have 22.990. we just have 1 sodium, and we have 35.453, and 1 chlorine. So together this will be 68.44 grams per mole. So let's use some dimensional analysis here. We want to place our grams opposite, so we're going to place grams down here, 68.44 grams per 1 mole of sodium chloride. In calculating that, you get a really small number, so I'm going to go ahead and put that into scientific notation. 8.56 times 10 to the negative 3 moles of sodium chloride. Now that we have our moles of solute, we need to just divide by our liters, which are given to us in the problem. 0.05 liters of solution. And then we have our molarity. So the molarity in this case will be 0.17 molar. So it's a 0.17 molar solution of sodium chloride. Problem number 5. 734 grams of lithium sulfate are dissolved to make 2,500 mils of solution. So we see two things in that we have to convert. We have grams, and we need to get this to moles. Also here we have milliliters, and we know that it's over liters of solution. So we're going to convert these just as one long problem. First we need to find our molar mass. So we have to write the correct formula for lithium sulfate. Make sure you crisscross those oxidation numbers. And there it is. Li2SO4. So now I'm calculating the molar mass, looking at each of these elements' atomic mass from the periodic table, and taking into account the number that we have within this formula. Total molar mass here is 109.94 grams per mole. Now we can start with the conversion. You have 734 grams of lithium sulfate. So the first thing we're going to do is put grams opposite so that we can convert grams to moles. We have our grams, 109.94 grams of lithium sulfate and 1 mole of lithium sulfate. So now that we have the mole, we can divide by our liters of solution. However, we do not have liters yet, and so we can do it like this, 2,500 milliliters. We know that in 1 liter, there are 1,000 milliliters. We can divide that out. Should equal 2.5 liters. Then we can plug this in. Moles divided by 2.5 liters. So our molarity, 2.67. We have a 2.67 molar solution of lithium sulfate. This is the last problem. I just want to remind you that if you are given a solution, and let's say it has a molarity for sulfuric acid, and so you have a 0.74 molar solution of sulfuric acid, H2SO4. This means that you have 0.74 moles per 1 liter of solution. So this is how molarity can be used as a conversion factor. So this is what we'll be doing next. We'll be converting to liters. And so if you were wanting to convert to liters, you would take the molarity and you'd say, okay, you have 1 liter per 0.74 moles. So now we have an additional conversion factor that we can use to convert from one unit to the next. That is the end of the molarity tutorial. Please remember to fill out the worksheet that accompanies this tutorial as you go through them.